the second topic in our section. It's the radians. Okay, so let's talk about what is a radian. Okay, so as a definition, so radian, one radian, it's so one radian, it's the R length of an angle equals radian radius r. Okay, so one radian is the r. It's the r length of an angle equals to the radian r. Okay, so what does that mean? What that means is if you're starting with a half circles in here, okay, and we're walking through from this r length in here, starting from this part, so we know this part in here is the radians r. Okay, and then if we find the r length in here, which is exactly r, and we can find there's an angle to make this happen, and we call it 1 radian. Okay, so we call this one 1 radian. And the way how we're doing it is by using a formula that is theta equals to s over r. Okay, and the thetas in here is represented by radian. S in here is represented by the arc length. And R in here represented by the radius. Okay, so that is the formulas how we're doing for the calculation. Okay, but after this one, so we have two different representations for an angle. We're using degree and we're using for the radians. Okay, but can we go back and forth from degree to radian, radian to degree? The answer is yes. Okay, and I'm going to show you guys how to do that. So the way how we're doing that is if we have a degree measure. Okay, so we're starting with using degree. So if we have a degree for an angle, all you needed to do is to multiply by a pi over 180 degree, and that will give you a radian. Okay, but if you're starting with the radian and you wanted to convert it back into the degree, what you needed to do is to multiply by the reciprocal of this number, and that turns out to be 180 degree divided by pi. That gives you degree. Okay, and that seems kind of a little bit complicated, but it's kind of get the idea. So what I'm gonna do is I'm going to show you guys a nice example for those, and then you guys can see how this is gonna work. Okay, so example for this one is I'm going to starting with 570 degree. Okay, so obviously this is a degree, and what I needed to do is to convert this one into radian. So by multiply by pi over 180 degree, and okay, so with the 570 degree, we multiply by pi over 180 degree, and that, if you simplify these things a little bit, it should be able to turn into 19 pi over 6, which is a radian. Okay, which is a radians in here. Okay, So the next one is, how do we change from radians to degree? So if we're starting with something different, like we starting 18 pi over 5, okay? How do we change that into degree? What we do is times 180 degree over pi, okay? If you do that, and then the pi and pi cross out, you simplify a little bit on top, you should be able to get 648 degree. So this is a degree. Okay. Make sure when you're writing for degrees on this, you should always have the little circles in here. Okay. So without the little circles in there, you're basically just writing 648 as a number. If you're writing for a number, it's not an angle. Okay. If it's not an angle, you're trying to write an angle, so that means that's completely wrong. So make sure you should always writing the little circles in here, which representing the angle. Okay. So that is how you're changing from radian to degree, degree to radian. So finally, we're moving into our last topic, which is how to find the arc length. Okay. How to find the arc length. Okay, so how do we find the arc length? The way how we write finding the arc length, if we go back a little bit, think about the formulas we had before, it's using that. So that is the radians equals to the arc length divided by the radius. Okay, and we changed it just a little bit. We should be able to get S equals to R times theta. Okay, so for this part right here, we have our formula. Okay, so in this formula, we have our arc length equals to the radius times the radian. And one thing you have to keep in mind is what? This theta right here should always writing in radian. Okay, so this theta should always in radian. Okay, if it's not a radian, you should change from the degree into radian. And if you're forgetting how to do it, you can always roll back for your video and then to find out how to do it from about 5 minutes ago. Okay, so how do we do this one? So here is a problem. I can give you an example, and hopefully that will be easy for you to grasp for this kind of stuff. Okay, so a circle has a radius R equals to 33 inches. Okay, 33 inches. So what we wanted to do is to find the arc length of a central angle is 60 degrees. Okay. So that is what we're going to do. We're going to find the arc length with a central angle is a 60 degree. In the same time, we have the radius is the 33 inches. And as what I said it before, this is a degree. But our formula, the theta, has to be in radians. So what we're going to do is to try to get the theta, try to get the 60 into the radian, then we can follow the formula to get into what we need it to be. Okay, so what we're going to do for that is starting to get 60 degree multiplied by the pi over 180 degree. Okay, so we do that, and that turns out to be pi over 3, and that is a radius. That is a radian. Okay, so after we have the radian, so we have this part right here. And what we needed is the radius which is right here. So now we can start using our formula by writing 33 inches multiplied by pi over 3 radian. Okay? And if you do the calculations for this, that gives you 11 pi. But since all the problems in here are using the units, so we should end this one with 11 pi inches. Since the arc length is also a distance, so that's how we should do it in this way. Okay? And here's all the things what we need to talk about in this sections. If you do have any questions, don't hesitate to send me an email. And I should be on my email very quickly and give it back to you. Okay? And I will see you in the next video.